In my last class, I had asked you all to do some examples of exercise 3.1. Did you all do? Pranjali, Jyoti, you were there in my last class. Did you all try those sums which I had told? Very good. So, voice is not audible. Just check it now whether it is audible or no. So today, if you have done those examples of exercise 3.1, and do you have any doubts in those examples, students? Examples of exercise 1, do you have any doubts? Okay, very good. So then we will start with the next concept of this topic, trigonometric functions, that is trigonometric ratios. The next concept is trigonometric ratios. In 10th standard, we have studied what are trigonometric ratios, right? In 10th standard, we have studied trigonometric ratios, trigonometry. Notes of first chapter, okay, I'll send you. In the group, I'll send it once again, okay? I'll send it afterwards. Now concentrate here, students. In 10th standard, we have studied what is trigonometry, right? And also we have studied trigonometric ratios. So we'll revise a little bit of 10th standard now. So you have to answer me quickly. How many trigonometric ratios are there, students? How many trigonometric ratios we know? We know 6 trigonometric ratios. Sin theta, cos theta, tan theta, sec theta, cosec theta, and cot theta. Right? And also we know how we define them. Suppose we have a right angle triangle, say triangle ABC, right angle at B. So what is hypotenuse here? Can you define what is hypotenuse, students? Yes, what is hypotenuse? Which is side opposite to right angle. What is hypotenuse? It is side opposite to right angle. Now here the right angle is at B, right? So which is side opposite to right angle? It is AC. So this is my hypotenuse. This is my hypotenuse. Hypotenuse is nothing but side opposite to right angle. And this is what? It is perpendicular. What is perpendicular? Line which makes angle 90 degrees with the base. This is base. Triangle's base. Base is BC, hypotenuse is AC, and perpendicular. Line which makes 90 degrees with the base. That is nothing but perpendicular. Perpendicular is AB. Right? So trigonometric ratios, how we define? I hope you all remember those. What is sin theta? What is sin theta, students? By looking at this diagram, can you define what is sin theta? Anyone? Anyone who can define sin theta? Yes. What is sin theta? It is nothing but perpendicular upon base. Perpendicular upon hypotenuse. Sorry. It is nothing but perpendicular upon hypotenuse. Next, what is cos theta? It is base by hypotenuse. You remember this, right? And what is tan theta? It is perpendicular upon base. It is perpendicular upon base. You all remember this, right? Have you all studied this? Students, have you all studied this? Trigonometric ratios, how we define? Sin theta is nothing but perpendicular upon hypotenuse. Cos theta it is nothing but base upon hypotenuse. Tan theta it is nothing but perpendicular upon base. Have you all studied this? Please answer. This is just the revision of 10th standard, students. In 10th standard we have studied these things. So just tell me whether you have studied this or no. Do you all remember this? Very good. We all remember this, right? These ratios, trigonometric ratios, we all remember. And what about remaining three trigonometric ratios? Sin theta, cosec theta, it sin theta. What is cosec theta? It is reciprocal of sin theta. So what it will become? Hypotenuse upon perpendicular. Since cosec theta is reciprocal of sin theta, it will be hypotenuse upon perpendicular. What is reciprocal of cos theta? It is sec theta. Reciprocal of cos theta is sec theta. So that would be hypotenuse upon base. That is hypotenuse upon base. Last, what is reciprocal of tan theta? It is cot theta. So that is nothing but base upon perpendicular. That is nothing but base upon perpendicular. Yes, students, reciprocal of sin theta is cosec theta, reciprocal of cos theta is sec theta, and reciprocal of tan theta is cot theta. Correct, right? Now these things, if some students are feeling it difficult, we have some mantra to remember this. So let us see what is that mantra here. Just remember this mantra. So if you remember this mantra, you can remember this definition. What is that mantra? Pandit Badri Prasad dot Hare Hare Bol. See, like these things we have to remember mathematics. We have to enjoy mathematics. Whenever you study maths, please enjoy it, or else it will be difficult for you all to learn. Okay, so just remember this mantra. Pandit Badri Prasad dot Hare Hare Bol. So why am I giving you this mantra? Hare Hare Bol. See, while remembering these definitions, some students will get confused whether sin theta is hypotenuse perpendicular upon hypotenuse or base upon hypotenuse, or cos theta is base upon hypotenuse or perpendicular upon hypotenuse. Like these things will get confused. Remember this, students. Is the video visible? So here, see here, students. If you are getting confused with the definitions, whether sin theta is perpendicular upon hypotenuse or base upon hypotenuse, you can use this mantra. What is this mantra? It says Pandit Badri Prasad Hare Hare Bol. See how you can remember this. Pandit, P. From first three words and next three words. In first three words, take starting words P, V, P. P, V, V. Next, from next three words, take first letters H, H, D. H, H, D. See, from first three words, I took numerators, that is P, V, P. From next three words, I again took the starting letters, that is H, H, D. H, H. First one, it is nothing but sin theta. Second one, it is nothing but cos theta. And third one, it is nothing but tan theta. See us with this. You can remember very easily. Okay. P by H, perpendicular upon hypotenuse, sin theta. B by H, base upon hypotenuse, cos theta. P by V, that is perpendicular upon base, that is tan theta. So by remembering this mantra, it will be easy for you all to remember the definitions very well. How you can remember? I hope you understood. Pandit Badri Prasad Hare Hare Bol. Take first letters P, V, P, that is P, V, P, numerators, and next three words take the denominators H, H, D, H, H, D. So what you get? First one, that is sin theta, second that is cos theta, and third one, that is tan theta. Perpendicular hypotenuse, sin theta. Perpendicular upon base upon hypotenuse, cos theta. Perpendicular upon base, tan theta. Do you all understand, students? And the remaining trigonometric ratios are reciprocals. Cosec theta mantra to remember these definitions. Do you all understand this? Is it easy to understand the definitions by just remembering this mantra? Pandit Hriday Prasad, Hare Hare Bol. Yes, students, I hope everyone understood. Is it easy to understand? I hope this mantra will help you all to remember the definitions perfectly. Is it useful? Very good. So just you can remember this mantra to remember these definitions. Because some students will feel it difficult to analyze whether sin theta is hypotenuse upon perpendicular upon hypotenuse or base upon hypotenuse. So that time you can make use of this mantra to verify your answers. Coming to the next part, we also have studied tan theta can also be written as sin theta by cos theta, right? And cot theta can also be written as cos theta by sin theta. These two things also we have studied. That is tan theta is equal to sin theta by cos theta and cot theta is equal to cos theta by sin theta. And also we have studied one table, right? Trigonometric ratios of some specified angles. This table everyone has studied, students? You all remember what is this table? They have studied trigonometric ratios of some specified angles. You all remember this table? Yes? You all remember? As we know, tan theta is nothing but sin theta by cos theta, right? We all know this. Tan theta is nothing but sin theta by cos theta. So tan theta, 0 by 1 is 0, 1 by 2 divided by 3 by 2. That is 1 by root 3, this is 1, root 3, and this is infinity. In fact, it is not defined. It is not defined. See, students, also we have remaining trigonometric ratios, cosec theta, sec theta, and cot theta. Everyone must should know this table, okay? This table is very important in trigonometry. Now what we know, cosec theta is reciprocal of sin theta, right? So cosec theta values you can write, and every value which is reciprocal of this sin theta value. Cosec 0 is 1 upon 0, that is not defined. Next, here 1 upon 1 by 2, that is 2. 1 upon 1 by root 2, that is root 2. 1 upon root 3 by 2, that is 2 by root 3. 1 upon 1, that is 1. Similarly, what is sec theta? It is reciprocal of cos theta. So all those values reciprocal of these values. 1 upon 1 is 1, that is 2 by root 3, that is root 2, 2, and not defined. Next, we know that cot theta is reciprocal of tan theta. 1 upon 0, not defined. 1 upon 1 by root 3, root 3, 1 upon 1, 1, 1 upon root 3. This is nothing but 0. See, students, to remember this table, it is very, very easy. You have to first know the reciprocal, which all are reciprocal of which all the trigonometric ratios. As we all know, cosec theta is reciprocal of sin theta, sec theta is reciprocal of cos theta, and cot theta is reciprocal of tan theta. More than this, what we know, that tan theta is equal to sin theta by cos theta, and cot theta is equal to cos theta by sin theta. These all things are clear? Are these first definitions clear, students? Reciprocals and quotient relations. Like reciprocals, we know that cosec theta is reciprocal of sin theta, sec theta is reciprocal of cos theta, and cot theta is reciprocal of tan theta. And also we know this quotient relation, tan theta is equals to sin theta by cos theta. To remember this whole table, it is very easy, students. If you know only one row, see, if you know only this single row, you can write the whole table on yourself. How I'll explain to you. See, the angle We have to study what, students? Signs of trigonometrization. Very, very important. Very, very important. See, this is 0 degree. This is 0 degree. Right? In fact, this is pi by 2. This is 0. This is 2 pi. And this is 3 pi by 2. This is pi, sorry. Yes, students? This is 0. This is pi by 2, that is 90. This is next pi, that is 180. And this is 3 pi by 2, 270. Do you all remember this? 90. So this 0 degree to 90 degree. This is first one. This whole thing is first one. Next is 90 degree to 180 degree. That is pi by 2 to pi. Here it is 180 degree to 270 degree. That is pi to 3 pi by 2. Lastly, 270 degree to 360 degree. 360 degree means it completes one full rotation, right? Here, we have to find the remaining angles, trigonometric ratios of remaining angles. If you know that particular table which we saw earlier from 0 to 90 degree angle, if you know that particular table, then that is enough to find the remaining angles. But before that, we have to first see what are the signs of trigonometric ratios. See your students. This first part, this two axis, coordinate axis will divide the plane into 4 parts, right? 1, 2, 3, 4. First part is called as first quadrant. Second part is called as second quadrant. Third part is called as third quadrant. And fourth part is called as fourth quadrant. So always the coordinate axis, x-axis as well as y-axis are nothing but coordinate axis. These coordinate axis will divide the plane into 4 parts and each part is called as quadrant. This we already have learned, right? Each part is called as quadrant. And here this is first 0 degree to 90 degree. Second quadrant is 90 degree to 180 degree. Third quadrant is 180 degree to 270 degree. And fourth quadrant is 270 degree to 360 degree. 270 means 3 pi by 2. 180 means pi. Pi by 2 means 90 degree. So first these things are they clear? Quadrants part, is it clear? Once again I repeat, coordinate axis always divide the plane into 4 parts, 4 equal parts in fact. And each part is called as quadrant. Each part is called as what? Quadrant. First quadrant, second quadrant, third quadrant, and fourth quadrant. First, is this clear to everyone? Till here? Okay, very good. Now again here I will give you one mantra, students. What is that mantra? See, if you remember these things, like using these mantras, it will be easy for you to remember throughout your life. This is the mantra which I will give you now. What is this? It says always go in anti-clockwise direction. First quadrant, then second quadrant, third quadrant, and fourth quadrant. So what does the CSTC rule say? A will come in first quadrant, S will come in second quadrant, T will come in third quadrant, and C will come in fourth quadrant. Right? What does that mean? In first quadrant we have A. That means all trigonometric ratios are positive in first quadrant. Similarly, coming to second quadrant, we have S. That means only sin theta is positive in second quadrant. Remaining all trigonometric ratios will be negative in second quadrant. Coming to third quadrant, we have T. That means only tan theta is positive in third quadrant. Remaining all trigonometric ratios will be negative in third quadrant. Coming to fourth, we have C. That is only cos theta is positive in fourth quadrant. Remaining all trigonometric ratios are negative in fourth quadrant. Is that clear to everyone? This is very important concept, students, because if we want to find the values of trigonometric ratios of different angles, science is most important. Whether in which quadrant it is lying or in what is the sign of the trigonometric ratio, these things must be clear to us first. Is this clear to everyone? ASTC rule? So whenever I say ASTC, everyone should understand what I am saying. About quadrants I am speaking, about which signs of trigonometric ratios I am speaking. Right? Is this thing clear? Is it clear to everyone? Is it clear to everyone, students? Is it clear, students? Okay, very good. One more thing, students, here. See, in first quadrant, all trigonometric ratios are positive. It is easy. Coming to second quadrant, I told that sin is positive and remaining all trigonometric ratios will be negative. But here, if sin is positive, then cosec is what? Cosec theta is nothing but 1 over sin theta, right? Cosec theta is reciprocal of sin theta. So if sin is positive, then of course cosec theta will be also positive. It is obvious, right? Since cosec theta is reciprocal of sin theta, in second quadrant, if I am saying that sin theta is positive, of Yes, students. So only cos 240 degree will be negative. Now tell me about this now. What will be tan 120 degree? Sine of what is sine of what? Tan 120 degree. First of all, tell me 120 degree lies in which quadrant? 120 degree lies in which quadrant? 120 degree lies in which quadrant, students? Answer quickly. 120 degree lies in which quadrant? See, 120 degree will lie in second quadrant, right? 120 degree will lie in second quadrant, right? And in second quadrant, what is sine of tan theta? Please answer this question. I want answer from you all. Very good. In second quadrant, tan theta is negative. See here, ASTC rule. First quadrant, second quadrant, third quadrant, fourth quadrant. In second quadrant, only sin theta is positive. Remaining quadrant notifications are negative. So in second quadrant, tan theta will be negative. So tan 120 degree will be negative. Tan 120 degree will be negative. Tell me about this cos 178 degree. Answer first. Cos 178 degree. Is it positive or negative? Is it positive or negative? Cos 178 degree. First of all, check in which quadrant it will lie. 178. In which quadrant it will lie? Yes, students, in which quadrant it will lie? 178 degree. In second quadrant, right? It will lie in second quadrant. So cos theta in second quadrant, what is the sign? What is sign of cos theta in second quadrant? Very good, it is negative, right? In second quadrant, only sin theta is positive. So cos will be negative. So the answer cos 178 degree will be negative. Tell me what is sin 110 degree? Sin 110 degree. 110 degree lies in which quadrant? 110 degree lies in which quadrant? It lies in second quadrant, right?